Last time we looked at 2 by 2 matrices and saw how to get the inverses. This time we look at 3 by 3 matrices, and we use this method called reduced row echelon form. There are other ways to do it, but this is a bit more intuitive and it makes sense. But remember, before we even get there, the inverse only exists, so the inverse exists if and only if, so I'm going to write if and only if, the determinant is not equal to 0. So how do you get the determinant of a 3 by 3 matrix? So what you do is, let's say I give you a generic 3 by 3 matrix, right? I gave you A, B, C, D, E, F, G, H, I. So I gave you some random matrix. These are all just some numbers, okay? Now the way you find the determinants is, imagine you have A, okay? So I do A, and now imagine you draw like a line across the row from A, and then a line from the column of A. So I'm going to cancel out A, B, C, and A, D, G. So imagine like I draw across it. I'm not going to draw it because otherwise it's going to look messy. But imagine these things then exist. Then you'd be left with the smaller matrix E, F, H, and I, right? I take the determinant of that matrix. So the determinant of that is just E times I minus F times H. So that's EI minus FH. Okay, I have that. And I'm going to subtract. Now do the same thing with B. So now I'm going to subtract, and I'm going to multiply by B. Now imagine you drew a line across the row from B. So I drew this line right here, and then a line in this column right here. So now I'm cancelling out A, B, C, and B, E, H. So you're left with D, F, G, and I. You take the determinant of D, F, G, I. So that's just D times I minus F times G. Okay, you have that. And now you add, now you do the same thing with C. So this is the final step. So you do C, now you cancel out the row in C. So you cancel out this whole row, and then you cancel out this whole column. So now you're left, you cancel out A, B, C, and C, F, I, and now you're left with D, E, G, and H. So you take the determinant of that matrix, you're left with D, H minus E, G. And that's it. That's the determinant of this 3 by 3 matrix. So this looks complicated because a lot of numbers and everything, but all you're doing is, you're taking the very first entry, A. So whatever the top left entry is, you're cancelling out that column and that row, and then taking the determinant of the remaining small matrix, 2 by 2 matrix, which we know how to get, and you're multiplying that by A. Then you're subtracting the multiple of the new matrix when you do the same thing with B, and you multiply that by B, and then you add that to the same thing you do with C when you cancel the row and the column, and then you take the determinant of the smaller 2 by 2 matrix. So let's do it with an example. It will make way more sense and it's easier. So let's say I gave you the matrix 1, 2, 2, 1, 2, 1, and 2, 1, 2. So I want to find, so this is, let's call this matrix A. I want to find the inverse of A. So A inverse, question mark. But before I even go there, I need to check, does this even have an inverse? So we check the determinant. So the determinant is going to be, so I have 1 right here. So I have 1 times the determinant of 2, 1, 1, 2. That's 2 times 2 is 4, minus 1 times 1 is 1. So 4 minus 1 is 3. So I have 3 minus 2, that 2 right there, times, now I have this matrix 1, 1, 2, 2. So I have 1 times 2 minus 1 times 2. So I have 2 minus 2. So that's just going to cancel out. And then I add that to this 2 right here. So 2 times the determinant of 1, 2, 2, 1. So that's 1 times 1 is 1, minus 2 times 2 is 4. So I have that. So I have 3 minus 0 plus 2 times minus 3, which is equal to 3 minus 6, which is negative 3. So an inverse does exist. So inverse exists. Now we need to find the inverse. So the way you do the reduced row echelon form is, you do this. So we have the matrix 1, 2, 2, 1, 2, 1, and 2, 1, 2. And I'm going to write the identity matrix on the other side. So I'm going to draw like this imaginary line, and I'm going to write the identity matrix. So I have 1, 0, 0, 0, 1, 0, and 0, 0, 1. So we're going to do something called row operations. So what I'm going to do is, I'm going to try to get this left-hand side. So this left-hand side, I'm going to try to get it look like their identity matrix by just reducing the rows. I'm going to try make this 0, this 0, this 0, and this is going to go to 0, this is going to go to 0, and this is going to go to 0. And then in the diagonal, I'm going to be left with 1, 1, and 1. And then whatever I do on this side, I'm also going to do on this at the same time. And when I end up getting the identity matrix on the left-hand side, I'll end up getting the inverse matrix on the right-hand side. So let's try to do it. It will make way more sense. The first thing I want to do is I want to get this point to 0. So how can I do that? Well, if I did 2, so this is row 1, this is row 2, and this is row 3, right? This R1 is row 1, R2 is row 2, R3 is row 3. So it's going to take some time, but we'll get there. So we're going to do 2 row 2 minus row 3. Let's do that. So what will we get? Well, row 1 is unchanged. We're left with 1, 2, 2. And then here, we're doing 2 row 2 minus row 3. So I'm going to do 2 times 1 minus 2. So that's 0. Then I'm going to do 2 times 2. So that's 4 minus row 3, 1. So 4 minus 1 is 3. So I'm left with 0, 3. Then I'm going to do 2 times 1 is 2 minus 2, 0. Okay, so we get another 0. We get a bonus 0. So that's nice. And then row 3, I'm going to leave it unchanged because I'm only working with row 2 over here. So whatever's first, you're only dealing with that row. So row 3 is still going to stay as 2, 1, 2. So I have that right there. And then on the other side, I do the exact same thing. So I have the top row remains unchanged. So I have 1, 0, 0. And then I do 2 row 2 minus row 3. So I do 0 minus 0. So that's 0. I do 2 times 1 minus 0. So that's 2. Then I do 2 times 0 minus 1. So that's minus 1. And then here again is this 0, 0, 1. So that's the first step. Okay, we have got 2 zeros. So the reduced row echelon form is when you have a zeros in this lower triangle and you have zeros in the upper triangle and the diagonals are just 1. So what can we do next? Well, next we want to get this to 0. So I'm going to do row 3 minus 2 row 1. Let's see what we get. So now the row 1 remains unchanged. So I have 1, 2, 2. Row 2 remains unchanged. So I have 0, 3, 0. And then I'm doing row 3 minus 2 row 1. So I'm doing 2 minus 2 times 1. So that's 0. So that goes away. And I'm doing 1 minus 2 times 2. So 1 minus 4 is negative 3. And then I'm doing 2 minus 2 times 2. So I'm doing 2 minus 4 is negative 2. And on the other side, I'm doing the exact same thing. So row 1 remains the same. Row 2 now is 0 to negative 1 from here. And then row 3 is going to be row 3 minus 2 row 1. So I'm going to do 0 minus 2 times 1. So I'm going to get minus 2. I'm going to do 0 minus 2 times 0 is just 0. I'm going to do 1 minus 2 times 0 is just 1. So now I have this. Okay, we're halfway there now. Now we just need to get this. We need to get this number, and this number to 0. So what can we do next? Well, we can do row 3 plus row 2. And what do we end up getting? Well, the first row remains the same. The second row remains the same. 0, 3, 0. Now the third row is going to be 0 plus 0. That's going to be a 0 still. We want to make sure we don't get rid of this 0 that we have. We want to keep that there. Now I'm going to do minus 3 plus 3. So that's 0. And I'm going to have minus 2 plus 0, which is going to be minus 2. Okay, so far so good. Now we do the same on the other side. So the first row remains unchanged. Second row remains unchanged. And the third row is just row 3 plus row 2. So minus 2 plus 0 is minus 2. 0 plus 2 is 2. And then 1 plus minus 1 is 0. Okay, so now we're more than halfway there. So we have done all of this. Now we need to move down here. So what do we do next? Well, what we can do is we can do 3 row 1 minus 2 row 2. Let's see what that gets us. So I'm going to do 3 minus 2 times 0. So that's just 3. I'm going to do 6 minus 2 times 3 is 6. So that's 0. So that goes away. I'm going to have 3 times 2 is 6. Minus 2 times 0 is still 6. So I'm going to have 3, 0, 6 in the top row. Then this stays at 0, 3, 0. And this goes to 0, 0, minus 2. On the other side, I'm going to have 3 row 1 minus 2 row 2. So I'm going to have 3 minus 2 times negative 2. So that's going to give me 7. 3 row 1. Oh, I'm doing 3 minus 2 row 2. So I'm going to do 3 minus 2 times 0. So I'm going to have 3. I'm going to have 3 times 0 minus 2 times 2. So that's minus 4. Then I'm going to have 0 minus 2. So that's 2. You have to be very careful with the way you do the arithmetic with these. So now I have 0, 2, minus 1. Then I have minus 2, 2, 0. Okay, we're just one step away. Or I guess 2 steps away. We need to get this to 0 and then we need to get the diagonals to 1, 1, and 1. So what do I do now? Well, let me just make sure we're good so far. We have 3, minus 4, and 2. We have 0, 2, minus 1, minus 2, 2, 0. Okay. Now what we're going to do is we're going to do row 1 plus 3, row 3. What are we going to get? Okay. I'm going to have 3 plus 0. So that's just 3. I'm going to have 0 plus 0 is just going to be 0. I'm going to have 6 plus minus 2 times 3. So that's 6 minus 6, which is 0. Okay, that goes away. Now this is 0, 3, 0 in the second row. And the third row is 0, 0, minus 2. I'm going to draw this imaginary line right here. And now we're going to do the same thing on this side. So I'm going to have 3 plus 3 times minus 2. So I'm going to have 3 minus 6 is minus 3. I'm going to have minus 4 plus 6 is going to be positive 2. I'm going to have 2 plus 0 is going to be 0. I'm going to have 0, 2, minus 1. I'm going to have minus 2, 2, and 0. Okay, so now we're basically there. It's one step away. Did I do this correctly? I had row 1 plus 3, row 3. So I had this plus this, row 1 plus 3, row 3. So I have 2 plus 3, row 3. Oh, this should be a 2 over here, not a 0. So this right here is a 2. That's my bad. So I have a minus 3, 2, 2, 0, 2, minus 1, minus 2, 2, 0. Okay, this makes way more sense. Now what do we do? Okay, we want to get a 1 over here, 1 over here, and 1 over here. So I can do row 1 divided by 3. I can do row 2 divided by 3. Then I can do row 3 divided by negative 2. So what do I end up getting? I end up getting 1, 0, 0. I'm getting 0, 1, 0. And I end up getting 0, 0, 1. So now that's done. And then the imaginary line right here. And I do the same thing for this side. So I do row 1 divided by 3. So I get negative 1, 2 over 3, 2 over 3. Row 2 divided by 3. So that's 0, 2 over 3, negative 1 over 3. And I do row 3 divided by negative 2. So I get 1, negative 1, and 0. And that's it. This is going to be our inverse matrix. So now